Welcome to all here in the session of mathematics. In today's session, we will discuss arithmetic progression. Before going to the arithmetic progression, first of all, we will discuss what is sequence, then what is series. Let us try the sequence first. You see, I am writing some numbers, suppose 3, 9, 27, 81, likewise goes on. So this can be written as 3 to the power 1, 3 square or 3 to the power 2, 3 cube or 3 to the power 3, 3 to the power 4, likewise goes on. So these numbers are written with some definite rule. That's why this one is called a sequence. Next, another example, 1 by 1, 1 by 2, 1 by 3, 1 by 4, likewise goes on. Also this one is another sequence. So from this we conclude that the sequence is, you can write the definition of the sequence, a list of numbers which can be written with some definite rule is called the sequence. So you can write here. In other words, the sequence is a function, that is, it is a mapping from the set of natural number n to the set of real number r. So here n is the domain. If you draw the Venn diagram of this sequence, then this one is a function f, which is a mapping from the set n to the set r. This one is the domain set, this one is the domain of the function, and this one is the codomain of the function. And codomain set is the set of real number, and domain set of this sequence is the set of natural number, and the range should be subset of the real number. So range of the sequence should be subset of the real number. This one is called range. Okay. Now the sequence is denoted by likewise symbol, that is, inside the curly bracket you can write fn, or you can write xn, or you can write an, likewise goes on, etc. So you see, if the sequence fn, we'll write sequence fn, in which form? The sequence fn can be written, you see, fn can be written as f1, f2, f3, dot 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 up to infinity. So these are the terms of the sequence, and this is the first term, this is the second term, and this is the third term of the sequence fn. And you can write the nth term, that one is called general term of the sequence fn, and up to infinite. xn, the sequence xn can be written as x1, x2, x3, likewise goes on, and the general term is xn. This is the nth term up to infinity. So likewise sequence can be written. Now in the sequence, the number of terms, if finite, then you can say this is finite sequence. That is called finite sequence. That means in the finite sequence, the number of terms are finite, and if the number of terms are not finite in the sequence, then you can say this one is infinite sequence. Okay, do you follow or not? Then we'll go to the some special sequence, that is Fibonacci sequence. Fibonacci sequence. Okay, one special type of sequence, that is called Fibonacci sequence. A sequence in which the terms are not arranged in a definite order, but the sequence generated by the recurrence relation, which is given by first term and second term. Each one is equal to 1, that is a1 is equal to a2 is equal to 1, and a3 can be obtained by a1 plus a2, that is sum of the two term, first two term a1 plus a2. Likewise an can be obtained, that is the general formula, an is equal to an minus 2 plus an minus 1 for n greater than 2. This is called the Fibonacci sequence. Now we will find the terms of the Fibonacci sequence. Here the first two terms a1 is equal to 1 and a2 is also equal to 1. Now we'll find a3. a3 means n is greater than 2. So 3 is greater than 2. So when you will replace n by 3, you will get this one is a3 minus 2, that is a1, a3 minus 1, that is a2. Okay, that is a1 plus a2. a1 is 1, a2 is 1, so 1 plus 1, that is 2. Now we'll get a4 likewise. a4 is replacing n by 4, that is 4 minus 2, a2 plus 4 minus 1, that is a3. a2 plus a3, just we have found a3 is equal to 2 and a2 is equal to 1. So 1 plus 2, that is nothing but the 3. Likewise, you can find a5. a5 is 5 minus 2, that is a3 plus a4. 5 minus 1 is a4. a3 is, what is that value? That is 2 plus a4, that is a4 is how much? 3. So 2 plus 3 is equal to 5. You can find a6. a6 is a4 plus a5. That is a4 is equal to 3 plus 5. This is nothing but the 8. So the Fibonacci sequence is 1, first term is 1, second term is 1, third term is 2, fourth term is 3, fifth term is 5, and sixth term is 8, likewise goes on. So this is special type of sequence which is called Fibonacci sequence, and you can find the terms of the Fibonacci sequence with the help of the general formula, that is an is equal to an minus 2 plus an minus 1 for n greater than 2, and the first term and the second term should be equal to 1. Next we'll go to the series. If xn be a real sequence, then sum of the terms of the sequence xn is called the series. That is, in other words, you can find if the sequence xn is equal to the sequence x1, this is nothing but the x1, x2, x3 dot 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 xn up to infinity, then the series xn can be written as, that is the symbol of sigma, or you can say sum of the terms n is equal to 1 to infinity, that is x1 plus x2 plus x3 plus dot 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 up to xn plus dot 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 up to infinity. Here the elements are infinite, not finite. That means this series itself is known as infinite series. If the terms are finite, then the series itself is known as finite series. That is, can be written as n is equal to 1 to k, suppose xn, then x1 plus x2 plus dot 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 up to xk. The last term is xk. So the terms are finite here, that's why this one is called finite series. So make it a note, then we'll go to the some questions of sequence and series. Take some questions. Find the indicated terms of the following sequence. Here the sequence given xn is equal to n minus 3 by 6. You have to find the 20th term, that is t20 and t31. Likewise an given, so these are also 3 xn is equal to n minus 3 by 4. You have to find t17, t39. Also the number 4 here, bit1, a1 and a2, they are both equal to 4, and an is equal to n minus 1 minus 2, n is greater than 2. So you can put from 3. You can find the 3 terms, first 3 terms. And bit 2, a1 is 5, and also the general term is given an is equal to an minus 1 plus 3 for all n greater than 1. Also you have to find the 3 terms of this. So I hope you can do all these problems. If you will face any difficulty, then you can message me. Next we will go to the arithmetic progression. Now we will take arithmetic progression. So arithmetic progression, this is a sequence of real numbers in which different elements are written by increasing or decreasing its previous elements by the same quantity, and this same quantity itself is known as the common difference, and it is denoted by the small letter, that is D. So the different elements of an AP can be written as, if the first term is A, then the second term will be A plus D, and the third term will be A plus 2D. Likewise, the nth term is A plus, here you see this one is the first term T1, this one is the T2 A plus 1D, T3 is A plus 2D, here third term this one is 2D. So nth term you can write A plus n minus 1 into D. So now the nth term from the beginning of the AP can be written as A plus n minus 1 into D. This is the formula to find any term of the AP if A and D known to us. Now if this one is the last term, then the nth term from the end is equal to, that is Tn, you can write Tn is equal to, the first term from the last is L, so L plus n minus 1, and D should be taken as minus D, that is the common difference should be taken as minus D when you have to find the nth term from the end. So this is nothing but the Tn is equal to L minus n minus 1 into D, where L is the last term. So you can find the nth term from the beginning by this formula and the nth term from the end by this formula. Okay, now make it a note. Now we'll discuss some problems. Now we'll take another question for AP, that is, which term of the sequence 72, 70, 68, 60, 66 likewise goes on is 40. That means he is asking which term of the sequence is 40. So first you have to check whether the given sequence is in AP or not. So solution: given the sequence 72, 70, 68, 66 likewise goes on. Here A is equal to 72 and D is equal to 70 minus 72, that is T2 minus T1, so that is minus 2. Also 68 minus 70, also that one can be written as 68 minus 70, also 66 minus 68. They are all equal to minus 2. So the given sequence is in AP. You can find first what is the common difference. If constant, then the given sequence is in AP. Let the nth term is 40. You have to ask which term is 40. That means your supposition should be likewise, let the nth term of the sequence is equal to 40. That implies an is equal to 40. All of you know that nth term an is equal to how much? A plus n minus 1 into D. For any sequence, this is the formula to find the an. First term plus n minus 1 into common difference. That is the nth term. So you can replace here an is equal to a plus n minus 1 into D is equal to 40. So we have a. What is a? That is 72 plus n minus 1. We have to find the value of n. So keep it as same. D. What is D? That is minus 2 is equal to 40. Or in other word, 72 minus 2n plus 2 is equal to 40, or 2n is equal to 74 minus 40, that is 34, or in other word n is equal to 34 by 2 is equal to 17. So you can solve yourself. So what is the value of n? N is equal to 17. Hence A17 or 17 term is equal to 40 of the sequence. So make it a note. Now we'll go to next problem. Now we'll take another questions for AP. That is 184 a term of the sequence this one or not? You have to check whether in this sequence 184 is there or not. You see solution here. First you have to check whether the sequence are in AP or not. Here clearly you can write clearly the sequence is in AP. Since 7 minus 3 is 4, 11 minus 7 is 4, so therefore common difference are same constant. That means the sequence is in AP. So now with the first term A is equal to 3 and the common difference D is equal to 7 minus 3, that is 4. Let you can write let An is equal to, that is 184. You have to check whether 184 is a number in this sequence or not, or is a term in this sequence or not. So first you have taken An is equal to 184. An is equal to how much? A plus n minus 1 into D is equal to 184. That is A is equal to how much? 3 plus n minus 1. You have to find n minus 1 into D is equal to 4, that is 184. Or in other word, that is 4n minus 4 is equal to 181, or 4n is equal to 181 plus 4, that is 185. That implies n is equal to 185 by 4, which is not a natural number. If this one is natural number, then this one is a term of the sequence. Since this one is a fractional number, is not a natural number, this one is not belongs to n, that is set of natural number. That's why that implies 184 is not a term of the given sequence. Okay, so make it a note. Now we'll go to the next question. That is, so that sum of m plus nth term and m minus nth term of an AP is twice of the mth term. Now let A be the first term of the AP and D be the common difference of an AP. So according to the questions, am plus n plus am minus n, m plus nth term, we know that nth term is equal to how much? A plus n minus 1 into D. So m plus nth term can be written as a plus m plus n minus 1 into D. Okay, plus m minus n, that means m minus nth term can be written as a plus m minus n minus 1 into D. That is nothing but the a plus a is 2a. D taking as common, we have left with m plus n minus 1 plus m minus n minus 1 into D, that is 2a plus here m plus n minus n cancel, that is 2m minus 2 into D. Taking 2 as common, a we have left with a plus m minus 1 into D. This is nothing but the mth term, that is twice of am, hence proved. So sum of m plus n and m minus nth term is equal to twice of mth term. Okay, so make it a note. So that's all for the today's session. If you face any difficulties, or any problem, then you can message me. I will clear your doubt. Until then, goodbye. Thank you.